12 men have walked on the moon. Every crew that did came home with its equipment damaged. Not by the vacuum, not by the temperature, which swings almost 300 degrees between sunlight and shadow. By the dust. It looks like the softest thing in the solar system. Gray, fine, powdery. The surface of a world that has been left alone for 4 billion years. That is exactly the problem. On Earth, dust gets worn smooth. Rivers tumble it, wind rounds it, rain washes it into corners. The moon has no rivers, no wind, and no rain. Nothing there has ever softened anything. So every grain on that surface is still shaped the way it was made, by rock being shattered over and over for 4 billion years. Sharp, angular, much of it welded into fragments of glass. The men who landed did not find a soft world. They found an abrasive, and it started grinding them down within hours. Start with how a place with no weather manages to produce dust at all. Nothing on the moon erodes in the way anything erodes here. What it has instead is bombardment. Micrometeorites, most of them smaller than a grain of sand, arrive continuously and at enormous speed, and there is no atmosphere to stop a single one of them. Each impact shatters rock into smaller pieces. Those pieces get hit in turn. That is the fine grinding, and it only ever works on the top. The depth comes from the larger hits, impacts big enough to dig into bedrock and throw it back out across the surface. Between them, they have buried the whole moon in broken rock, a few meters of it on the dark plains, deeper on the older highlands. But it is not only broken. Some of those impacts release enough energy to melt what they hit, and the melt splashes and cools instantly in the vacuum, welding nearby fragments into lumps of glass with the debris frozen inside them. Mature lunar soil is full of them. So the ground is a mixture of shattered mineral and impact glass. And neither has ever been rounded off by anything because there is nothing there to do the rounding. Then there is the size. A significant fraction of the particles are smaller than 20 micrometers. Below that scale, dust stops behaving like sand and starts behaving like smoke. It hangs, it drifts, and it goes wherever air goes, including into lungs. Put those two properties together, needle sharp and small enough to breathe, and it becomes clear why the surface of the moon is not a beach. None of which explains how anybody stands on it. Loose, broken rock, meters deep, is not obviously something you can set a spacecraft down on. And before anyone went, that was a serious worry. The astronomer Thomas Gold argued the layer could be deep enough and soft enough to be a genuine hazard to a lander. It was taken seriously. It was part of why the first machines sent there were uncrewed. They settled it in 1966. Luna 9 came down, stayed on top, and sent pictures back. Surveyor 1 followed and measured what it was standing on. The surface holds. It holds because only the top centimeter or two is loose. Below that, the same material is packed hard. The 4 billion years that broke the rock up have been compacting it the whole time. Armstrong reported sinking in about 1/8 of an inch. Meanwhile, crews trying to drive sample tubes down by 1/2 meter had to hammer them, and the deep drill on Apollo 15 jammed in the compacted layers badly enough that getting it back out cost the crew part of their day. The rover had no trouble either. Its wheels were open wire mesh, built for a surface nobody was certain about, and they sank 1 centimeter or so into the loose top and rolled on the packed layer underneath. So nothing sinks. That was never the problem. The problem is that 1 loose centimeter on top, because a wheel rolling through it has to throw it somewhere. Before any of that could be a problem, the dust had to be disturbed. That happened on the way down. An engine firing at a surface with no atmosphere does not raise a cloud. It fires the surface outwards. On the later landings, the crews reported the ground disappearing beneath them in the final seconds. Not into billowing smoke, but into a fast, flat sheet of material driven horizontally by the exhaust, thick enough to hide the very ground they were trying to land on. The commander is flying a machine with minutes of fuel toward a surface he can no longer see, using instruments and the horizon. Once on foot, the behavior got stranger. Kick a stone here and the dust it raises hangs, drifts and settles slowly because air holds it up. On the moon, there is nothing to hold anything up. Material thrown by a boot leaves in a clean arc, travels exactly as far as physics says it will, and lands. All of it at once, with no cloud left behind and nothing still floating. The result is unnervingly sharp. Every grain moves like a small projectile, and the plume of a footstep has an edge to it because there is no air to blur it. Drive across it and the same physics scales up. The rover's wheels through long arcs of debris behind and above the vehicle. The crews called them rooster tails, and each one came straight back down onto whatever happened to be underneath, which, on a vehicle carrying two men and their instruments, was the men and their instruments. There is also a demonstration of what all this does over time, and it was retrieved by hand. Apollo 12 set down within walking distance of Surveyor 3, an uncrewed lander that had been sitting on the surface for 2.5 years. The crew cut pieces off it and brought them home. The parts had been sandblasted by their own landing engine and coated by the surface itself. Physical evidence returned to Earth of what the moon does to hardware that simply stands still on it. There is a second property, and it is the one that turned a nuisance into a problem nobody could work around. The dust sticks. The lunar surface sits unprotected in ultraviolet light and the solar wind, and that leaves the grains electrically charged. Charged dust does not fall off a surface. It clings to fabric, to metal, to glass, to itself. Crews tried to beat it off. They tried brushing. Neither works properly. Brushing a charged abrasive across a suit mostly grinds it in. So it came inside. The lunar module was a sealed cabin the size of a small van, and every time the crew came back through the hatch, they brought the moon in with them. In weightlessness, once the ascent stage lifted off, whatever had settled came up off the floor and hung in the air with them. There is one more detail, and it is the strangest one. Cameras on an early uncrewed lander photographed a faint glow along the horizon after sunset, and Apollo crews reported and sketched something similar from orbit, a thin band of light where there should have been nothing at all. One explanation is dust lifted clear of the ground by electrostatic charge, hanging above the surface of an airless world. The mechanism is still argued about. The observation is not. The Apollo 17 crew spent about 75 hours on the surface, and roughly 22 of those outside. 3 working days. That was enough to visibly wear out equipment built by the most heavily funded engineering program in history. The outer layers of the gloves were worn through in places. Same with the boots. These were not thin gloves. They were multi-layer pressure garments, and the surface of the moon sanded them down over 3 days of handling tools and rock. The joints stiffened as dust worked into them, and a stiff joint on a pressurized suit is not an inconvenience. Every movement in a pressure suit already costs effort. Grit in the bearings makes a hand close harder, and hands were the tool that mattered. Faceplates were scratched. Camera lenses were scratched. Radiators which shed heat by radiating it into space collected a gray coating that made them worse at exactly the job they existed to do. So equipment ran hotter as the mission went on, and the seals suffered. Sample containers were designed to close on a vacuum and hold it, so that the rocks would arrive on Earth having never touched air. Dust on the sealing surfaces worked against them, and the vacuum did not always survive the trip home. The moon contaminated the evidence of itself. Then there is the most famous failure, because it looks like slapstick and was nearly serious. A fender broke off the rover on Apollo 17. Without it, the wheel threw a continuous plume of dust over the vehicle and the 2 men riding it, coating the radiators, the instruments, and the crew. They fixed it with laminated maps and tape, and the repair held. A wheel arch. The rover drove about 22 miles in total on that mission, and it had been carried 250,000 to get there. What nearly ended the driving was a strip of fiberglass over one wheel. The equipment could be replaced. The crews could not. Every account of the smell agrees, across separate missions: burnt gunpowder. That is what the moon smells like once it is inside a cabin and there is air for it to smell in. Nobody has fully explained it, and it does not survive the trip home. Samples brought back to Earth do not smell of anything. Harrison Schmitt, the only professional geologist to walk on the moon, took his helmet off after a day of work and had a reaction he named himself: lunar hay fever. Blocked sinuses, sneezing, watering eyes. It passed within hours. It came back after the next excursion. Eugene Cernan, in the debrief afterwards, described the dust as the single most restricting factor of working on the lunar surface. Above the temperature, above the vacuum, above the low gravity. Not the most dangerous, the most limiting, the thing that decided what could and could not be done. And here it is worth being careful, because this is where the topic usually gets exaggerated. Nobody knows what long-term exposure would do to a human being. The studies showing damage to lung tissue were done on simulated lunar soil in laboratories on Earth, not on the real thing and not on people. What is documented from Apollo is short-term irritation in men who were exposed for hours and then went home. Nobody has ever stayed long enough to find out what happens after that. 3 days of work visibly degraded suits, seals, optics, and cooling. A permanent base is not 3 days. It is months, then years, of people going out and coming back through a hatch, every cycle carrying more of the surface inside with them. Every seal on every airlock, every bearing in every joint, every radiator and solar panel and camera lens sits in the same abrasive, charged, inescapable powder. This is a named, open engineering problem. There is no version of returning to the moon for good that does not have to solve it first, and it has not been solved. That is not the reason nobody has been back. The reasons for that are mostly money and politics, and it would be dishonest to pretend otherwise. But it is one of the reasons that going back to stay is harder than going back to visit. The last man left the surface in December 1972. Everything that has landed since has been robotic, and machines do not take their helmets off and sneeze. From here, it is the gentlest object in the sky, a soft gray disk, the one thing in astronomy that has never frightened anybody. The surface everyone imagines as powder. It is powder. That is the problem. 4 billion years of being hit, with nothing to smooth the wreckage afterwards, and a charge that makes it hold on to whatever it touches. A world that grinds down anything set on it and then follows it indoors. Of every place humans have physically reached, the moon is the only one that has ever touched us back. And it has not stopped being what it is. It is up there tonight, exactly as sharp as it was in 1972, waiting for whoever comes next.